If you've ever looked up and seen your cat casually balanced on a high-rise balcony railing, you've probably had this heart-stopping moment. Your cat slips on a damp ledge and tumbles over the side, falling toward the pavement dozens of feet below. You prepare yourself for the absolute worst. But then, when you reach the ground, the cat is often shaken, maybe has a minor sprain, but essentially walks away and goes on with its day. Meanwhile, if you fell from that same height, you'd end up in the emergency room with fatal trauma. So what's going on? How do cats survive falls from heights that would instantly shatter our bodies and walk away looking almost unbothered? The answer isn't a single thing. It's a whole system stacked layer on layer, built over millions of years of evolution. And it doesn't just apply to your house cat. It applies to felines of all sizes, from wild tree dwellers to the absolute masters of acrobatic survival. Once you understand how it works, you'll never look at a cat's high-altitude antics the same way again. Before we get into the physics, let's clear something up, because the premise of this video is actually a little misleading, and intentionally so. Falls do injure and kill cats. In the real world, falling from a high building can and does cause severe trauma to animals. They break bones, damage their lungs, and suffer internal trauma. Sometimes they die. The reason we don't think about this is partly due to survivorship bias. When a cat falls and doesn't survive, owners rarely bring them to the emergency clinic, meaning veterinary studies showing a 90% survival rate are only telling part of the story. You're seeing the survivors. The ones that didn't make it are already gone. But, and this is the important part, cats do survive these extreme drops far, far more often than we would, and the reasons why are genuinely remarkable. The first line of defense is something we share with cats, but in a very different magnitude: terminal velocity. When you fall, gravity pulls you down, while air resistance pushes back. Eventually, those two forces balance out, and you stop accelerating. For a human, that terminal velocity sits around 120 miles per hour. That is a lethal, bone-crushing speed. But for an average-sized cat, terminal velocity tops out at only about 60 miles per hour. That is half our speed. Because of their light bones, thick fur, and small size, cats have a very high surface area to weight ratio. They literally cannot fall as fast as we do. It acts as a built-in speed limiter, ensuring that no matter how high the drop is, they will never hit the ground at the terrifying velocities a human would. And there's another factor on top of that: orientation. When humans fall, we flail, tumble, and often land head first or rigid-legged. Cats don't. Within a fraction of a second of beginning a fall, a cat's inner ear, the vestibular system, detects which way is down. This triggers what is called the righting reflex. What happens next is a highly coordinated feat of biomechanics. Because a cat has an incredibly flexible spine and lacks a functional collarbone, it can twist its front half in one direction while rotating its back half in the other. It conserves angular momentum mid-air, rotating its body without having to push off of anything. In less than 3 feet of free fall, the cat has completely flipped itself around, eyes locked on the target, limbs pointing downward to face the impact. And here's something that doesn't get talked about enough: the parachute effect. This is where the physics get truly counterintuitive. You would assume that the higher the fall, the worse the injuries, but veterinary studies have shown a bizarre pattern. Cats that fall from 7 stories or higher actually tend to have fewer fractures than those falling from lower heights. Why? It's all about how they react to terminal velocity. During a shorter fall, say 3 to 5 stories, the cat is still accelerating. Its vestibular system is actively stimulated, causing the cat to tense up and extend its limbs straight down. When it lands, all that force is concentrated on stiff, vulnerable bones. But once a cat falls past 5 stories and hits terminal velocity, it stops accelerating. The sensation of falling fades, and the inner ear relaxes.
Instead of tensing, the cat sprawls its legs outward like a flying squirrel, maximizing drag. It essentially turns its body into a parachute, slowing its descent and preparing to distribute the impact across its entire body instead of just its feet. Now we get to what is probably the most fascinating part of this whole story. Landing on your feet is useless if your skeleton snaps like dry twigs upon impact. But a cat's skeletal structure is designed to deform and absorb energy. As we mentioned, they lack a rigid collarbone. Their shoulder blades are attached to the rest of their body by muscle and tendon, not bone. This means their front shoulders can compress and slide, acting like high-end shock absorbers. When they land, their knees and elbows bend, distributing the deceleration force through massive, springy muscle groups, rather than transferring the shock directly to their joints and spine. It's a biological crumple zone that dissipates the energy of the impact before it can reach their vital organs. It's not just a hard landing, it's a controlled deceleration. So why can't we do any of this? Fair question, and the honest answer comes down to our evolutionary history. We are ground-dwelling primates. For millions of years, our ancestors optimized for walking, running, and carrying things on 2 feet. To do that, we needed heavy, rigid skeletons, upright posture, and massive bodies. We solved the mobility problem by staying on the ground and building tools. The cat solved it by mastering the trees. As arboreal predators, their ancestors spent millions of years chasing prey through the forest canopy. In that environment, falling isn't a rare accident, it's a daily hazard. They couldn't afford to die from a single misstep, so they evolved a body that treated gravity not as an enemy, but as a manageable physical constraint. They optimized for flexibility and lightweight durability, trading off sheer skeletal strength for aerial survival. We built ladders and stairs. They built a body that didn't need them. So the next time you see your cat napping on a high windowsill or effortlessly leaping down from a bookshelf, remember what's actually happening. If they ever slip, the vestibular system hits first, a biological gyroscope instantly orienting them in midair. Then their unique anatomy kicks in, twisting their body to face the ground. If the fall is high enough, terminal velocity takes over, triggering a relaxing parachute pose that slows them down and spreads the impact. And when they finally touch down, a collarbone-free muscular suspension system acts as a soft shock absorber, sparing their bones and organs. It's not one defense, it's 4 defenses layered on top of each other, refined over millions of years of living in the treetops. Cats aren't immune to gravity, they are adapted to it. There's the difference. And that terrifying plunge, from their perspective, is a challenge their bodies were literally built to survive.